is how to graph ratio tables. Let's look at our do now. Jack bought 4 packs of hamburger that are on sale and paid a total of $16. Use a ratio table to determine how much additional he will pay to buy 3 more packs of hamburger at the same store. So this is a review of our ratio tables. So it cost him $16 for 4 packs, but he wants to buy 3 more packs, so that's 7 packs. Can 4 be scaled up, scale 4 to 7? I don't think so. So what are we going to have to do? Well, we have to break it down. We have to scale backward, scale down. So how can I scale down 16 and 4? I'm going to divide both numbers by 4. That's going to be 4, 1. Now I need to scale forward by 7, and it's $28 for 7 packs of hamburger patties. So if you are given an order pair like 4 or 5, do you know which number is the x and which number is the y? 4 is the x, 5 is the y. So 4 will go on the x-axis, 5 will go on the y-axis. You can express information in a table as a set of order pairs. To see patterns, graph the order pairs on a coordinate plane. So for example, the table below shows the cost for different phone plans. Verizon is about $50 per month, Sprint $40 per month, and Boost is $35. I think it's Boost Mobile, $35 per month. Complete the tables. In 1 month, Verizon will cost you $50. 2 months will be $100. 3 months will be $150. In 4 months it'll be $200. The order pair is 1 and 50, 2 and 100, 3 and 150, and 4 and 200. So in Sprint, it costs $40 per month. 1 month, $40. 2 months, $80. 3 months, $120. 4 months, $160. So in 1 month, $40. 2 months, $80. 3 months, $120. 4 is $160. So the x, or the dependent, because I know in science you've been learning about dependent variables and independent variable dry mix. We're going to be learning that in a month from now. So the dependent, wait, no, wait, let me make sure I did it. Dry mix. I apologize. The independent variable are the months, and the cost is the dependent. The cost depends on the months, the number of months. So we don't know the cost until we know the month. Depends. All right, next one. So in 1 month, Boost Mobile costs $35. 2 months, $70. 3 months, $105, and 4 months, $140. So the order pair is 1 and 35, 2 and 70, 3 and 105, 4 is 140. So the table lists this information as order pairs, month, and cost. So we're going to list the blue represents, the green will be Sprint, and the red will be Boost. So label the x-axis and y-axis. So if we go back, the x-axis is month and cost. So this will be cost, and this will be, wait, let me go back to my thing. Let's go back. Month is the x-axis, and y-axis are cost. So month, x-axis, cost. Again, in science, you've been learning about dry mix, dependent variables, and independent variables. We are going to be learning that soon. So dry mix. This is the independent. This is the dependent. The cost depends on the month. The number of months. Usually time is always the independent. So let's go back to Verizon. Verizon costs 1 month 50, 2 months 100. So let's go back to this graph. What do we like to count this by? If this is 0, do we like to count by tens? I'm going to count by 20s. 20, 40, 60, 80, 100. Interval by 20s. So, and this is the months. 1, 2, 3, 4, 5, 6. 1 month with Verizon is $50. 2 months is $100. 3 months is $150. 4 months is $200. So this represents fee for Verizon. Oh, wait, I should have used blue. The green will represent Sprint. 1 month costs $40. 2 months costs $80. 3 months costs $120. 4 months costs $160. So 1 month is $40. 2 months cost $80. 3 months cost $120. 4 months cost $160. So this represents Verizon Sprint. The red will represent Boost Mobile. 1 month 35, 2 months 70, 3 month 105, 4 month 140. So 1 month 35, 2 months 70, 3 months 105, 4 months 1. I can't remember what 4 months was. 4 months 140. 4 months 140. And this is Boost. What can you tell me about these numbers? Which one is going at a higher rate? Verizon, as you can see, the line is getting steeper. It's going at a faster rate of change, which we're going to be learning soon. Which is, by the way, 7th grade material, pre-AP. In 7th grade, they do learn about this. Which one's going at a slower rate of change? The Boost Mobile, as you can see, is not as steep. So make a prediction or educated guess. Predict the cost of Verizon for 6 months. Verizon is the blue. Well, I almost had it. Well, see, I stopped at 4 months. So every 50, it keeps going 50. So the pattern is 50, 100, 150, 200, 250. I predict it's going to be $300. Predict the cost of Boost for 5 months. So let's see, Boost for 5 months. 35, 70, 105, 140, 35 more, be 175, and it is true, right there, 175. At what month will Verizon and Sprint cost the same? At what month? Verizon will cost the same as Sprint in what month? Let's see. So going back, Verizon, their costs are 50 in 1 month, 100 in 2 months, 150 in 3 months, 200 in 4 months. Sprint, which is color green, is 1 month $40, $80 for 2 months, $120 for 3 months, $160 for 4 months, $200. The two numbers are the same, or 200. So it's $200. For Verizon, it will take 4 months. Sprint will take it for $200. Sprint will take 5 months. All right, so let's do another one. The table shows the distance Kaylee travels on her scooter 1, 2, 3, and 4 hours. The table also lists the information as ordered pairs, time, comma, distance. Label the x-axis and y-axis, graph the ordered pair. So the x-axis is time, the y-axis is distance. Remember, x, y. So time, distance. All right, we just did that. Now graph the ordered pair. So 1 is the time, 4 is the distance. 2, 8, 3, 12, 4, 16. So 1, 4, 2, 8, 3, 12, 4, 16. So we just graphed it. And describe the pattern in the graph. From what I can tell in the pattern, for every hour, it goes up 4. The distance goes up 4. Every hour, the distance goes up 4. For every hour, the distance goes up 4. And do we need to do any predictions here? No predictions here. All right, so last but not least, John makes trail mix to take on his hike. For every cup of raisin, he adds 2 cups of mixed nuts. John creates a table below to represent the ratio. Complete the table. 1 cup of raisin, 2 cups of mixed nut. If he double his raisins, then it'll be 4. If he triples it, it will be 6. So for every 1 cup of raisin, you'll have 2 cups of mixed nuts. Or you can think about for every 2 cups, he'll have a 1 cup, which is half the amount. So complete the thing. Or another way you can do it is, what's the relationship from 1 to 2 times 2? So 2 times 2 is 4. 3 times 2 is 6, the relationship. So, do the table and graph correctly represent the ratio of raisins to mixed nuts? 1 is 2. 2 is 4. 3 is 6. No, it does not represent the same thing. This is a straight line that goes constant, is a constant rate of change. This one is like a curvature. So if the graph does not represent correctly graph the relationship, I just did. On the same graph above using a different color, I did. What order pairs did you use to create your graph? I used 1, 2, 2, 4, 3, 6. What do the x-axis represent? The number of cups of raisin. What do these y-axis represent? The mixed nuts. If John adds 12 cups of mixed nuts, how many cups of raisins should he add? What is the relationship here? It seems like the mixed nut is double what the raisin is. So would it be 6? 12 is double of 6. So 6 cups. And if you graph it, 6, 12, so let's see, 3, 12, 4, 8, 5, 10, 6, 12. And yes, it would work. So this is how you graph ratio tables. You are given an x and a y, or a deep or an independent variable or a dependent variable, and then you're able to graph it, x-axis to y-axis, and then you can make predictions from this graph. Graphing ratio tables.